Good evening, everyone. I'm Anne, the coach of the Siemens mobile team. And today we have the honor of presenting as the last team and therefore wrap up the CUT presentation with some nice music performances that you should really look forward to. But before we start with our presentation, let me introduce our team to you. We have our customer Asa, our project lead Sardosh, and of course our talented developers Paul, Julia, Giuseppe, Marcel, and Lucas. So now, without further ado, I want to hand over to Giuseppe, who is going to tell you what our project C Major is about.
Okay, thank you, Anne. Okay, let's go right into our first visionary scenario. Imagine you want to create a musical piece, so probably you will think to a conventional way to do that, maybe a piano or a guitar. But of course, to be able to play this instrument, you need to learn a lot, maybe for years. That's why we created an app to make music. Imagine you just smile in front of your guitar or do a particular movement. Of course, nothing will happen. So we explored and found new ways of interaction to make music with your mobile device. And now I want to invite my colleagues to explain you how this works.
Okay, thank you, Giuseppe. So we'll start with our AR instrument here. So basically, here we have an AR setup where I can create virtual objects and interact with these objects to be able to play different types of music. For example, now I can play chords. Sorry, it's not connected. And I can also be able to add different types of objects as well. For example, if I want to play notes, normal notes, I'm playing here bass guitar. So basically, I have this. Of course, I can edit all of these to be able to make the instrument setup I want to be personalized to my preferences. And now, from here, we move to the next instrument.
So the second instrument we want to showcase you is the violin. And here we have implemented an interaction which you already know from our previous presentation. And this is the drawing interaction. So here we have a canvas, and on the left-hand side, you can draw and play notes out of a scale, like this. And on the right-hand side, the 3 rows represent notes out of a certain chord. So you could play them particular, or you could also combine them to play a chord, like this. And here, in every instrument you see now in our presentation, we have an edit button where you can set up different types and adjust instruments further. And with this, to the drums.
Okay. So if you remember the design review, you might already know this interaction. It's where I can shake my phone in different directions to create different sounds. And the way it works is basically we put sensor data in a physical system and with a ball in the bounding box, and whenever the ball collides with the bounding box, it creates a note. And like this, I'm going to play the drums. All right.
Well, that was really nice.
Well, it works. Okay.
Now let's go to our second visionary scenario, where our user is Simone, and she has a friend, Simon, and of course they want to create music together. That's why we implemented collaboration. So now I'll let my colleague Paul to explain how this works in further details.
Okay, thank you, Pepe. Now let me introduce you to our collaboration feature. When you hear collaboration in the context of music, you might think, okay, one person is going to play one instrument and another person is playing another instrument. Well, we wanted to do something a little different and explore also what technology can offer us. So we also noticed that traditional instruments have certain limitations, namely that, for example, only one person can play them at a time. It would be really awkward otherwise, which is actually part of what makes them so hard to play, because in order to play an instrument, you have to get 3 ingredients right. You need to know what note to play, or to define the note pitch. You have to define the note timing, or when you want to play the note. And you also have to define note intensity, or how hard you want to play the note. Now in our app, we're using multi-peer connectivity to distribute these tasks of providing these 3 different types of data across 3 different people using 3 different interactions. And we recombine the data wherever we want to create the sound. And what we're doing by that is, first of all, lowering the learning curve of the user, because, for example, if you shake your phone and want to define when to play a note, it's way easier not having to worry about what note comes out in the end. And second of all, we can choose interactions that are much more suited to provide a certain type of data. For example, a touch interaction is much more versatile for providing pitch information than, for example, a motion interaction is. Okay, so in our demo scenario, the setup is as follows. The devices should already be connected, and now Marcel is going to provide us with a chord progression using the AR interaction. So whenever Marcel is playing a chord, the current chord gets updated on every device. So Lucas can, for example, play the violin using the touch interaction, and whenever Marcel changes the chord, the notes that Lucas is playing will change as well. And now a third person can join in using the motion interaction to then play based on the note that Lucas is providing, but adding some rhythm to it, basically, yeah, defining when to play a note. And this is not connected to a speaker. Well. Okay. All right. So, excuse me for a second, because while we're connecting to a Bluetooth speaker, let's welcome our customer Asa on the stage, and let's hope this still works out. Okay, now we're connected to something. All right. So, okay. All right. Yeah. Now I'm going to provide you with a rhythm, so we can play together. And we also need our conductor, Julia, so it's a little easier to play together. All right. Yeah. Okay. Well. Okay. So, as you could hear, there were some issues. We would have really liked to show you the actual piece we practiced. We can we go to backup slides? Because apparently there's...
We'll be trying the string that we favored.
Yeah.
No, we don't have time anymore.
right. So that was kind of a challenge. We had different challenges too. Obviously, our main goal was to make music, but really, what is music? And what is an instrument? I mean, do you just play it somehow and it creates some kind of sound and then it's music? Not really, right? So we kind of needed to define those things, and here's what we did. We decided that music really has to have some rhythm to be music, and also has to be played in a certain scale. And we decided an instrument is something that can create a note or a combination of notes, so chords. And after that, of course, we also had to decide how we play an instrument really to create music. So this is what we did. We really worked on 3 different user interactions. We capture motion, touch, and AR input. And of course, music alone is not enough. We also wanted to create harmonic music. So we synchronize chords and notes across devices. We play different instruments that sound harmonic together, and we can choose between various scales. And if you don't want to play alone, we can currently collaborate with up to 7 people. And as you've seen in the live demo or in the backup, we distribute functionality with the chord and note sharing, and we synchronize some data as, for example, the metronome and the scale that we play in. Loading, saving, and editing music is not fully implemented yet. We can edit existing instruments, as you've seen in the Edit drop-down menu. Saving musical pieces and sending them to your friends needs work in the future. So what else can be done in the future? We could add AI assistants for choosing what chord and notes are played and when. We could add global collaboration so that we don't need to be in the same network when we collaborate. We could add the sampling of our own sounds. And of course, we can up with totally new features, because this is a very experimental and creative project. There are hundreds of ways to expand the app. And with that, I want to thank our customer ASA for this project. It was really, really cool, and we hope we reach the expectations.
So you certainly did. Thank you very much. This has been a really cool project for me too. So something completely different from many of the other topics that we did. So one of the instruments didn't work fully in the live demo. That's just the way it is. Everyone's invited to try these things out afterwards in the buffet. It's really, really fun to get into. What struck me about the project is we were really creative at the beginning, trying things out, trying to get the sensors right, and then came sort of a lot of just hard work, just to get a little faster, a little more accurate, and then we had to toss a lot of stuff out. And it was really not until like 2 weeks ago that we actually started making music and not noise, and that's when it got fun. So I'd like to thank you for that fun part of it. Yeah, thank you.